Kia ora. Here's our last example. So again, you start looking for the molecular iron peak, and you can see there are some peaks over there. Can be a little bit tricky, but that one, you can see there's 1 unit apart. That looks nearly 1-to-1, but because they're not 2 units apart, you know it's not bromine. Also, you know it's not bromine because the molar mass is too low. So not bromine, not chlorine, not nitrogen, and nitrogen is because there's no odd number of nitrogen presence because it's not an odd number, and we don't have the ratio 2 units apart of either 1-to-1 for bromine or 3-to-1 for chlorine. There's also no real peaks down here in the infrared to support a halogen, and this is a bit difficult to see any NH peaks because of this parabola, but we can see clearly that there's nothing over there between the 40 and 60, so it's unlikely that you will have a carbon that is bonded to a nitrogen. So again, the alkyls you can match up. This one's quite downfield, so it could be a variety of things, but we know that that methyl definitely shows there's that alkyl over there. Right, we do have this lovely little peak over here, which is a hydrogen bonded to a carbon of a double bond alkene, and we have the alkene peak. Remember, narrow, medium peak, unlike the carbonyl, which is a strong finger-like peak. We can also see that we have an alkene because we have these peaks between 100 and 150. The further apart they are, the more different they are. If it's between 100 and 120, you've got a terminal alkene, so a carbon that's bonded to 2 hydrogens. If you've got round about 140 or 120 to 140, you'll probably have got a carbon that's bonded to a hydrogen and an alkyl. And between 40 and 160, a carbon bonded to 2 alkyls. Because this is just about on the dot there, we are not too sure which one this is, but we know it's not a terminal alkene. Okay, we can see there is a M plus minus 1 peak, so that is, remember, whenever we lose a hydrogen from and make a stable carbocation. So it could be something like oxygen. We do have oxygen over here, so we can link up that M plus minus 1 peak to the OH parabola over here. And we can say, well, this peak over here supports the evidence that I have a carbon that is bonded to an oxygen. So it supports my alcohol. Right. I don't have a carbonyl, so remember to point that out. So there's no peaks in this area or in the one up here. So in terms of a formula, it's 86, subtract the 16 from my alcohol, leaving me with 70. If I divide it by 12, I have a mass of 60 from the carbon and 10 from the hydrogen, giving me a formula of C5H10O. And that does match unsaturation due to 1 carbon double bond, or at least 1 double bond, and we know I have at least 1 double bond. Kia ora.